Hello, everybody. Let's take a look at functions now. All programming languages, they have the ability for you to define a small segment of code and then save that and put it into a library for later use. This is really important because often you will have a segment of code or a program which has things in it that you would need to use in future programs. We call this reusable code. And another thing about functions is that if we continue to build up our library of these functions, then we can make our programming shorter in the future. Now, as an example, let's take our AT content program that we did earlier, and let's look at how we can make that into a function. So let's put that calculation here. And we have declared my DNA, that's just a variable, and it's set to be this string of bases here. Then, in order to calculate the AT content, we need to know how many counts we have, or how many A bases we have, how many T we have. And then the calculation is pretty simple. We just add the A and the T together, divide by the total length of this, and that gives us the AT content. Now, if this is something that we needed to repeat over and over again, then one way that we could do this would be we could just copy that calculation and we could paste it in our program wherever we needed it. But then we'd be adding a lot of extra lines to our program, and it would be kind of inconvenient to do that. It would be much better if we had some way to make that code, actually just this part of the code here, if we could make that into a special little item, and then we could just include it in our programs as we go further. So that's what we're going to do here. Before we do that, we need to make sure that this program actually does work. So let's just run the program and look at the output that we get. So I'm going to just run the module, and let's look at the output. All right. Well, we don't have any output because I didn't print anything out. So let's put our print statement in here, and then we can print out the AT content. So I typed in the line print AT content equals, and then we'll print out the variable AT content. Okay, now I am just using a comma here to separate the values, so that works nicely. And alternately, we could have used a plus sign here, and we could have converted that numeric value to a string, and that works as well. But now let's bring over the output and let's see what we get from that. So here's the output. Okay, AT content equals, and we have this number here. All right, so that is what we got in our previous example, so that's fine. We've proven that that is correct. But one thing that we can do here is this extremely long number is kind of meaningless to us. And so if we could cut off a bunch of those digits, that would be great. And in the videos that you've seen earlier, I've shown you one way you can do that. There's also another way that you can do it, which is probably easier to do. So let's go ahead and I'll show you how to do that now, and we'll include that in our function coming up. If we wanted to, we can use a rounding function, and it's just called round, R-O-U-N-D. And then we have to use some more parentheses. So be careful about the number of parentheses here. We have to have a matching number on the left and on the right. So if I want to round this AT content, I can put a comma, and then how many digits do I want to print out? So I can put a 2 after that. Then I've got to close that parentheses so that we'll have a matching number of them. So now we have a matching number. So we have the parentheses that go with our rounding function, and then we have the outer parentheses that go with print. Now when we run the program, we'll see that now we don't get all those extra digits because we're just going to round it to 2. So let's run the program and we'll look at the output. So the output comes up in a huge window. Let me make it smaller. And I'll bring that over, and you can see the output now only has 2 digits to the right of the decimal. So in the videos that I've shown you so far, there are now a couple of ways that you can go about formatting your output. So here's another approach you can use, the round function. All right, now back to functions. Let's take our code, just this part, the calculation, and let's make that into a function. So the calculation is going to be the same thing, so we can copy this. So I'm just going to copy these 4 lines of code with a Control-C. And normally you want to put your functions up above all the rest of your code, and I'll explain why coming up. So I'm going to paste this in, and we'll do a little bit of editing. Instead of calling it my DNA this time, I'm going to just make a generic variable just called DNA. Okay, so I'm just going to subtract or delete the my DNA part of this. Now, I'm going to add a function definition. And in order to define a function, we just use def. So that is the define feature of Python. So we'll define a function. And whenever we do that, we need to give it a name. So I am going to call my function the get at content. Okay, so let's do get underscore at underscore content. So you have to give it a name. And if you want the function to be able to accept input data, then you have to give it a variable here. Okay, so let's put a DNA there. And as with the for loop, we have to put the colon after the name of this. Now, also like the for loop, we have to do an indentation. So remember, this is very error prone. So when you do an indentation, you could just type some spaces, or you could use the tab key. But don't mix those up. Just use one or the other. So I'm going to use the tab key, and I'm going to tab these lines over. So when they're indented, then that indicates that all of those lines, they belong to the function get at content. Now, the function is going to do a calculation, and when it finishes with the calculation, it has to return a value. So you have to define your function. You have to put in the code that defines what the function is going to do, and then you have to return the value that it produces. So at the very bottom, we have to have a return statement. So return, and then what are we returning? Well, the thing that we want to return, of course, is the valuable thing that it computed, which is our at content. So we'll do at underscore content, and that'll be returned by the function. So there. So that is the definition of a function. Now, whenever we want to calculate the at content of anything, we can just use one line in our program. We can call get at content. And when we call it, we are going to send in the sequence of DNA that we want to use in the calculation. Then let's look at how we can use that in our main program. I'm going to keep the code that we have here. Okay, I'm going to keep all of that. So we're going to compute the at content for this long string. We're going to do it twice. We'll do it once in the main program, and then we're going to call the function. So let's put a comment here. Okay, just put a comment. I'm going to call function. Okay, we're going to call function to compute our at content. So let's call the function, and we'll pass in the DNA that we want it to use in the computation, which is my DNA shown here. So to call the function, here's how we do that. We are going to have a new variable here, my at content, and here's how we call the function. We just use the name of the function, and then in parentheses, we need to give it the DNA sequence that we want it to use in the calculation. So in this example, let's just give it this string here. So that's a shorter string of DNA, and notice that they are all in uppercase. Whenever the function does the calculation, it's going to return a value. Okay, so it's going to return the at content here. That value is saved in whatever variable you place here. So when you call the function, you need to have a local variable that's going to accept the value computed by the function. Then we're going to have the name of the function, and we're going to pass in the DNA we want it to work on. So we have this assignment statement. Okay, you've got the equal sign there. So you call the function on the right-hand side, it returns a value, and it's saved by the variable that you have on the left-hand side. All right, now once we have that value, we can just print it out. So we'll print out the value that's returned by the function, and we'll convert it to a string since it's going to be a number. So we'll convert it to a string here. So that's one way you can output this. Okay, so then let's run the program and let's look at the output. We'll bring the output window over. and here is the result that we get. So in this example, we get 0.45 when it was working on this string of bases shown here. The AT content from our code that's in the main program still gives us the 069. So that came from this print statement over there. So here then is what you can do. You can copy and paste this code over and over again, or you can make a function which has the code in it, and whenever you want to compute the AT content, we just need to have the one line. Okay, so we can call the function here, we get the result, then we can print it out. So we can use that function over and over again, anytime that we want to. Now, let's call that function with our original myDNA up there, and let's look at the output we get from it. So I'm just going to take these two lines of code, and I'm going to copy them, and I'll paste them down here. And this time, instead of calling the function getAtContent with an actual string of bases, I'm going to use the variable myDNA. So it's my_DNA. So now I'm going to send in to the function this entire string here, which is contained within the variable myDNA. So the function will accept it, it will compute the AT content, it will return it, and we'll save it in my AT content here. So then we'll print it out. So I'm reusing the myAtContent variable. So up here, the first time I call, it's going to get the result of that string. Then I'm just going to reuse that same variable and let it receive the value when I'm calling it with the myDNA variable that contains this other long string here. And that's okay. Once I've printed out the value up there for my AT content, then I've seen what it is, and I don't need to make another variable. I can just reuse that same one, and I'll calculate my AT content and print it out again here. So I'm calling the function again. So let's run the program and look at the output. So we'll bring over the output. And this time, this is from the previous run. So if you're running the Python shell, you know that if you don't clear it out, it's going to show your previous results. And each time you run your program anew, it starts out with restart. So this last part, we have the AT content from the main program as we did before. Then I call the function, and it returns 045 when I'm using this string of DNA here. Then I do it again, and I get the output from the myDNA variable that's down here, right? So I've still got this long string of digits that's showing up here whenever I call the function and I give it the myDNA. So, all right, so let's see if we can work on our function just a little bit so that it always gives us just 2 digits instead of this really long extra string of digits here that are pretty much meaningless because the accuracy is not that good. It just gives us a bunch of extra digits we don't really want. So if we want to control the number of digits, one improvement we can make to our function is we can use that rounding function. So instead of returning AT_content with those long set of digits to the right of the decimal, then let's format it better. Let's use our round function here, and we have a parentheses, and you can specify how many digits that you want. Okay, so I'll use 2, but this can be any number of digits that you want here, including 0 if you want to. So now, whenever the function does its calculation and it returns AT content, then it'll be much better formatted for us. So we will now just have 2 digits to the right of the decimal. Let's go down to our program and let's add a couple of other calls to this function. So let's look at these 2 calls here. So I'm going to embed those, but I'm not going to use variables this time. I'm just going to embed the call to the function directly in the print statement. So you've seen before when that we can have a variable that we can use to contain information, or if you want to just call a function directly, then you can put it inside the parentheses of your print statement, and then the data that's returned by the function will be printed directly from here. The only drawback to using this technique is that if you want to use the value returned by the function later on in your program, then it's not going to be available. So if you want to retain the value from a function, then you need a variable for that. If you don't care about it, if you just want to print out the value it returns, then you don't have to use the variable. You can just call it directly here. And what are we doing? Well, we're going to call getAtContent with yet a third kind or third string here. And then we're going to call it with some lowercase letters. So our DNA sequences, you've seen them both in uppercase and lowercase. So let's try calling the function here with a new uppercase version and a lowercase version. So now we'll run the program and we'll look at the output. Let's bring in the output window and let's look at the answers. So this one is from our first call. I mean, it's computed by the main program. We didn't get that by calling a function. Here we got 0.45 when we made this call here. Then I call it with my DNA, my underscore DNA, and we got the 0.69, which matches the calculation we did in the main program. Then I'm calling it with yet a third sequence of DNA shown there, and the result of that's 53. But when I call it with lowercase, then I don't get anything. Well, actually, I guess I do get something. I get 0 instead. So the value that's returned when I make that fourth call is 0. All right, so why do we get 0 there? If we look at our program, if we look at the function, then it's checking for an uppercase A and it's checking uppercase T to get the DNA count. Well, we could manipulate the code so we could test for a uppercase A or a lowercase a, or same thing with a T. But if we don't really want to add the extra code to do that, there's something really simple that we can do. And here, when the data that comes in is in the DNA variable, we can make that uppercase always. So we have a function that will let us do that. So this variable here, whatever it contains, and it'll contain whatever we call the function with, we can make that all uppercase. So let's modify our function again, and let's make all of our input data uppercase before we do the count. So here's the code we need for that. So I'm just going to place that right after DNA, and when I put it in here, then it's the DNA.upper. So that means that if the DNA that we send in happens to be in lowercase, then this will convert it to uppercase. Then after that happens, then we'll count all the A's. So this will work just fine. So let's do the same thing down here for the T count. So we'll do an upper, and we'll convert the DNA to upper there, and then we'll count the number of T's. So that will now allow us to send in either uppercase or lowercase DNA sequences. Let's go ahead and try that. So we'll run the program and look at it again. So let's bring our output over and let's look at what we get now. So in this case, we have the output from the program and we have the output for the other cases, and notice that the lowercase now does give us 0.52. So when we sent in this string of lowercase, then it converted it to uppercase before it did the count, and we got now a non-zero value from here for this. The other thing that this will do is if you happen to have a mixture of lowercase and uppercase, then if you do the upper function, then it will convert everything to uppercase, even though part of it may be uppercase to begin with. Now let's move forward with one more step. If we have a function that computes the AT content, then we don't need to repeat that in the program itself. So let's just delete this part of our main program out altogether, and we'll just call the function to do all the calculations for us. So let's see what we have. We still need to define my DNA. That's in the main program. And then we computed this, so we don't need that either. We can take that out and delete this, and then we can just call the function. So here are the calls to the function. Okay, we can call getAtContent with that string. We print that out. And here I'm calling it with my DNA. I'm using this variable, my DNA. So we pass that in, and then we print out the result. And these last two lines, we just call the function from within the print statement to get the output. Now, I've been talking about a main program and I've been talking about a function. So what do I mean by that? Well, the function is defined here. A function is a self-contained segment of code that computes something. So that's kind of a definition. The main program is shown down here. And the main program does whatever it does, and it calls these functions to do the calculation that it needs to do. So the main program, it's kind of like the main mothership, if you will, here, and it has all of its helpers, and these helpers are these little functions that we define. So you can think of it that way. So all these functions are kind of workers that are used by the main program. The placement of the code is very important. You have to define your functions prior to your main program. So let me show you what happens if you don't. So I'm going to take this function, and I'm just going to temporarily just cut it from here, and I'll paste it down at the bottom. So now the function's at the bottom, but I'm trying to call the function in the main program here before I get to the bottom. So when I run this program, then I am going to get errors. So you'll see that the output that comes up, I get the red output, which means error, and it says that the name getAtContent's not defined. So in order to define your function, in order to use your function, you must define it. And you have to define it before it's used. So if I try to call the myAtContent here, then the main program doesn't know what that is because it always goes top to bottom. So your functions have to go first. Okay, so let's put it back up above everything else where it belongs. So that you must watch for. The other things that are happening here is we have this variable that's defined as part of the function. Now this thing is known by a couple of names. The polite name for it is the formal argument, but we commonly call it a dummy argument because this variable, it does not have a value until you give it one by calling the function. So when I call the function, getAtContent, I have to send it something. So I have to send in some information, and this is called the actual argument, the actual parameter or the actual argument. So it's the real data. So we have that, and when you call the function, that information is sent in, and this dummy argument takes on that value. Then it computes whatever it needs to using that. And it's important for us to be able to do that because the dummy argument or the formal argument, it has to be able to take on any string of DNA sequences that we pass into it. Otherwise, the function wouldn't be very useful. If it only had to accept the same value over and over, it would not be useful at all. So each time we call the function, we can send it different information into this dummy argument by sending it an actual argument with data. Now, we have this little program, and now that we've erased it, we've erased the code from the main function. Let's run the program one more time, and let's see what the output looks like. So now we have the output, and it's the same as we had before. So now we have a nicely formatted output. We call the function each time, and we send it, in this case, 4 different arguments, 4 different strings of DNA, and it gives us the AtContent for each. So those are the basics then of how you can define and use a function. Before I close this, I want to show you just a couple of other functions, and they don't really relate to AtContent. They're just examples. But let's look at a couple of other functions that might be functions that you would want to use, over and over again. And the first one I want to show you is just a temperature conversion function. So let's take a look at that. If you have multiple functions, you still put them all above the main program. So in this case, I'm just going to add a little space here, and I'm going to place the function in here. So in this function, I'm calling it, and let's look at the notation. You have to use DEF, don't forget that. Then you pick a name for it, and then you have to list any formal parameters the function is going to need. So this one is just a simple conversion from Celsius to Fahrenheit. So I'm going to use this dummy argument Celsius in my calculation, so I can send in any Celsius value that I want. Then I'm going to convert the equivalent value in Fahrenheit. Then I'm going to return that calculated value rounded to 2 decimal places. And now that's the definition of the function. Let's call the function down here, and let's input some data before we call the function. So I'm going to ask for a temperature in Celsius, and that'll be input from the keyboard, and then we'll call the function and print out both the Celsius value and the Fahrenheit value. So I'll put the code right here. So here's the call to the function. Well, actually, this is a prompt. We're not calling the function, we're asking for input. All right, so I want a temperature in degrees Celsius, and I'm going to use the input function. So this will print to the screen, enter the temperature in Celsius, so we type in the number, hit return, and that's saved in temp C. Now the calculation is a division, and it's looking at real numbers. So if we want to match the data with the calculation, then we have to make sure that the type is correct. So that's why the float is placed over here. So float just means that we want to take this input value that we type in, even though we type in 20, which could be an integer. We want to take that and we want to make sure that it's interpreted as a real number. So that's what the float does. And also be sure to notice the parentheses. We have 2 left, we have 2 right. So this will prompt us to type in the temperature. Then let's call the function, and we just do that by using an assignment statement this time. So we'll put that here. And we're going to save the output in variable temp underscore f. So we'll call the function c to f. We'll send it this temp underscore c that we just typed in from the keyboard. The function will return the temperature in Fahrenheit. Then I'm going to print out both of those values. So let's put a line of code here that will do that. And we'll drop it in right here. So here's the print statement. Okay, so the print statement is going to print out the Celsius temperature and a comma. Then it'll print out Celsius equals, then there's a comma. Then the Fahrenheit temperature, comma, and the word Fahrenheit. So then it will print out, say, 10 Celsius equals whatever Fahrenheit. All right, let's run the program, and let's type in a temperature, and let's have it converted to Fahrenheit. So here's our output window, and we have all the previous stuff that we had from the AT_content function, but now we're down here. We're going to enter the temperature in Celsius. So I'm going to type in 100 degrees Celsius. Then I'll hit enter. That number is read in from the keyboard, and I print out 100 Celsius is 212 Fahrenheit. So there's a little function that converts Celsius to Fahrenheit. That might be something you want to keep for future use. Now, let's move on and look at another example of a function. And this one's going to be to compute the body mass index. So you may or may not have seen what the body mass index is. So let's just get our function, and I'm going to put that at the top where functions go. So I'll put some space here. And I'll just paste in the function and then go over it. So I'm going to define a function called BMI for body mass index. Now, the body mass index is computed by taking your weight in pounds and dividing that by the square of your height in inches, then multiplying that result by 703. So that gets us the English units instead of the other kind of units. So the function then is going to accept weight, feet, and inches. So note that you can have as many variables as you want here. You just have to separate them with commas. So the function is going to accept the weight, and it's going to accept our height in feet and then our height in inches. We're going to compute the total height by multiplying the feet by 12 and then adding on the inches. And that's just because this calculation requires the height to be in inches, but we don't typically give our height as 65 inches or whatever. We usually say 5 feet 2 or 6 feet 1. So we'll just stick with our normal way of giving our height, and we'll let our program convert it. So that's what that line does. Then the function will accept these 3 numbers. It will compute the body mass index. It returns it with a rounding of 2, giving us 2 digits to the right of the decimal. So you can stack up your functions at the top of your program just like that. Okay, now to finish this up, let's ask for an input for the parameters that we need to compute the body mass index. So let's go ahead and put that in here. Okay, so we'll add that to the bottom of our program. So we'll have a input. So this goes to the screen. Enter your weight in pounds. We'll convert it to float. We'll save it in the variable WT. Enter your height in feet. That goes to the screen. We'll convert it to float, and we'll save it in a variable FT. I guess I didn't get the height in inches, so we need that one too. So let's put that down here. So this one is going to be to enter the inches part of your height. We'll convert that to float. We'll save it as inches. So now we have the three parameters we need to call the function. So we'll go ahead and we'll call the function. So remember that the call to the function looks like this. We just use the name of the function, and in this case, if the function is expecting three numbers, we have to send it three numbers. If I don't, then it will give me an error. So we'll use the assignment statement again. Call the body mass index function. It does its thing. It returns the body mass index. We'll save it in our variable called body mass. And then, to be done with it, we just print out that information. So let's put that here. And we'll print out your body mass index is, comma, and body mass. So here's the call to the function. It returns body mass. We'll print it out. Let's run the program and look at the outputs. All right, I'll bring over the output. And we're still going from top to bottom with our program. So here's the AT content output. Here's our inner temperature in Celsius. I did 100 before. And now we're down to the part where we're going to type in our information to get body mass index. Okay, so let's say our weight in pounds is 170. And what's your height in feet? So let's suppose I'm 6 and 8, 6 feet 8. So then I'll hit enter. And these three numbers are passed into our body mass index function. It calculates the equivalent body mass index. It returns it. We print it out. So you can see now that these functions, they can be whatever you want. And it's kind of up to what your application is as to what things you want to make into a function. But things that you're going to use over and over again, those just scream out to be functions. It's also very good programming practice to try to do this as much as possible, and it's called making your code modular. So you have building blocks. So you have these functions that are building blocks. Then in your main program, you use those building blocks in order to do whatever your main program needs to do. So it makes your main program shorter, and it keeps these functions self-contained and modularized, and it makes it easy to reuse. So that's your introduction to functions in Python. So we are going to stop here, but we'll look at functions and use them in future videos that are coming up. But that's all for now.